Right, so Pure 2, Jan 2022. This is an exciting day, okay? Let's go through this then. Okay, question number 1. The table below shows corresponding values of x and y for y equals 2 to the power of 5 minus root x. Now, we've noticed lately with the log questions that they're in the newer papers, we have this part I and II. Okay, this is all algebra manipulation. So once we get the first part done correctly, we're going to be okay. So it says use the trapezium rule with all values of y in the given table and obtain an estimate. So first of all, a few people got this wrong because of the height. The height is the difference between our x coordinates, okay? And you'll notice they need to be constant because that's the height of our strips, okay? So what's the difference between 5 and 0.5?
No, you mean 5.
Sorry, I mean 5 and 5.5. I know I said the answer. What happened there? Right, so our height equals 0.5. Now, you're given this formula in the formula sheet. Okay? So, to work out the area, it's really simple. We are going to do our height divided by 2, lots of our first y value, plus our last y value, plus 2 lots of the middle. Now, something that I noticed when marking this was that a lot of people struggled to put this in a calculator and obtain the correct answer. Okay? So, when I put this in, remember I get an approximate value. Okay, so then it wants it to 2 decimal places. I'm going to round it to 11.79. So now once we've done that was the easiest part of the question, 3 marks. Okay, it then says use your answer to part A and making your method clear, estimate the following. Now we really have to make our method clear here. So first of all, always go back to what did we actually have in the question? Okay, we had 2. Oh, there we go. Right, this is what we had in the question. So with these types of questions, this is what we're looking for. We had 2 to the power of 5 minus root x. Okay? What's the difference? It's like playing spot the difference between what we have and what's going on here.
2 plus 5.
It's a multiple of what? 2. Okay? 2 to the power of 6 minus root 5 is, in fact, 2 times 2 to the power of 5 minus root x. Why is this true? Because this is 2 to the power of 1. And what do we do when we multiply when we have the same base? We add. Okay? So essentially, we could say that this is the integral of 2 lots of 2 to the 5 minus root x. Now, because this is a multiple, we can actually bring the 2 on the outside. So this is 2 lots of the integral between 7 and 5, 2 to the power of 5 minus root x with respect to x. We've just worked out that this is in fact 11.79. So technically then, 2 times 11.79 will give us this answer, which is going to give me 23.57. Okay? We're going to do the exact same, but this time I'm going to manipulate the second one. Okay? What do we notice about the original one and this one? Spot the difference.
So you need to integrate 3 and then you already have the...
Yeah. So all we've done is add 3.
Yeah.
So now we can split them up. Because we're adding them here, technically, we can do the integral of 3 between 7 and 5 plus the integral of 2 to the power of 5 minus root x with respect to x between 7 and 5. We already know that this is what? 11.79. Okay, so now we just need to integrate 3 with respect to x. So if we integrate 3, what do we get? 3x. So now, what is 3x between 7 and 5? We're going to have 3 times 7, 21 minus 3 times 5. So 21 minus 15 is 6. Plus the integral of this, which we already know is
11.79.
11.79. This gives me my total of 17.79. So there we have it. Nice and easy, 7 marks. Just needed some manipulation. Right, who... Oh. Okay, question 2. The curve C has this equation. Find dy by dx given each term in its simplest form. Okay, we love these questions. Right? So let's differentiate this. Bring the power down. A half times 27. 27 over 2.
Who said 16?
Did someone say 16? Fools. Okay, and then we decrease the power by 1. What's a half take away 1? Minus a half. And guys, if you don't know this, use your calculator, please. Okay? It's not like anyone's going to make a mistake, like 20 plus 28 is, I don't know, 58 or something ridiculous, are they? You know? So, now we're going to bring the power down. And then we're going to decrease 1 for the power. What's 3 over 2 take away 1? A half. Brilliant. And then minus 20? 0. Absolutely. Right, guys, it's 2 marks. Okay, we've been doing this since GCSE. Okay? It says, hence, find... Now, I'm going to read this word really slowly because some people really struggle to understand what this word means. Coordinates. Okay? Coordinates look like this. They're in a bracket, x and y. Yeah? What do we know about stationary points? The gradient equals 0. So this means, okay, if the gradient equals 0, this means, this means that this equals 0. Now, some people really overcomplicated everything here. Let's just take a deep breath. Perfect. Okay. Right. So 27 over 2x to the negative a half equals 3 over 2x to the positive a half. Yeah? Then what could I do? Multiply both sides by 2. Divide both sides by 3. So I get 9x to the negative a half equals x to the half. Okay? What happens now, though, if I multiply both sides by x to the negative a half?
So you remove... No, you don't remove.
Why don't you add, why don't you multiply by positive half?
Positive a half.
Yeah, because we shift you. They'll give you 1 like there. No,
They'll remove the x and then
But I'm going to divide. Guys, it's really simple. If I divide both sides by negative a half, okay, I'm going to get 9 equals, what's a half? Minus a half. X. Okay, I saw some crazy things here where people were using like hidden quadratics, substitution. It's really simple. Okay? Everyone happy with what I've done? Yeah? Okay, where did you get stuck? I didn't get extra x's. I just divided both sides by x to the minus half. Imagine it this way. If you had 9x cubed equals x squared. Yeah? Technically, we could divide both sides by x squared, couldn't we? So this is where the extra x's come from. I'm just showing you what I'm doing. They're not extra. No, they're not. I'm just showing you. So x squared divided by x squared is 1, and then this is going to give me 9x equals 1. Do you see? Yeah? Okay, so then, now we know that x equals 9. If it wants coordinates...
You apply.
I put my coordinates, miss.
Great. What does y equal? 27 lots of 9 to the half minus 9 lots of 3 over 2 minus 20. When I substitute this in, I should get 34. Perfect. Now, how do coordinates look? 9, comma, 34. Okay. So we should all be happy with this, yeah? Brilliant. Then says find d2y by dx squared. Okay, so
Differentiate.
I need to differentiate again.
Substitute x.
Exactly. Oh my. Oh. So I'm going to differentiate this again. Okay, so bring the power down. Minus 27 over 2 times negative a half. Minus 27 over 4.
X to the power of minus 3 over 2.
X and minus a half minus 3 over 2. Take away 1. Bring the power down. Minus 3 over 4x. And then a half take away 1. Minus a half. Okay, so now, if I need to know the nature of the stationary point, the first thing I'm going to do is substitute in 9. So I'm going to get minus 27 over 4. 9 lots of minus 3 over 2. Minus 3 over 4, 9 to the negative a half. This is actually going to give me minus a half. Okay, minus a half is less than 0. Therefore, what type of point do we have? Brilliant. Therefore, maximum. Now, some people didn't state this. You're not going to get full marks if you don't write that full sentence at the end. Yeah? It's not even a full sentence, is it? It's just a word, but you know what I mean. Okay, find the first 4 terms in ascending powers of x of the binomial expansion. Now, I've got to say, I think only 2 people got this right. The full thing.
Oh, the first thing. 2 people.
Oh, yeah, you are one of them. Well done, well done. Right, so let's have a look then. So, first of all, let's find the first 4 terms in ascending powers of x. So it's to the power of 8. So, we know that we're going to have 8c0 times 2 to the power of 8. Phone's away, thank you. Times minus kx over 4 to the power of 0. Now, this is going to be the first 4 terms, okay? So we're going to have 2 to the 7 times minus kx over 4 to the power of 1. 8c2 times 2 to the 6 times minus kx over 4 to the power of 2. 8c3 times 2 to the power of 5 times minus kx over 4 to the power of 3. Okay, so you're literally going to put this into your calculator. I'm going to have 256. Okay, we're going to have negative 256 kx. Now remember, on this one we need to square the k and square the x and obviously the quarter. So we're going to have 112 k squared x squared. Then we're going to have minus 28 k cubed x cubed. So then when we write this out, we're going to have 256 minus 256 kx plus 112 k squared x squared minus 28 k cubed x cubed plus ... Please make sure you write this. Some of you just left that. Okay, it's not good practice to do that. We need to write the whole thing out. Now, it says, in the expansion of f of x, the constant term is 3 times the coefficient of x. Okay? So, step 1. Okay, so first things first. We know 5 minus 3x. So we know if we were to multiply 5 minus 3x by, okay, and then I'm going to move this here. What is it asked us for? Okay, guys, so the constant term is 3 times the coefficient of x. Okay, so the constant term can only be worked out. The constant term is the term without the x. How many ways can we multiply 2 numbers, multiply this out to get a constant? 1. We can only do 5 times 256. Okay? So this is 5 times 256. This is our constants term here. Okay? And this is 1,280. Right, now we need, how are we going to find the coefficient of x? The only way to get the coefficient of x is to do 5 times minus 256 kx. Okay. Plus, and then the only other way to get a coefficient of x is if we did minus 3x times 256.
Yeah, Yeah.
What do you mean, why?
I don't understand this problem.
Come on, tell me. You tell me why.
I don't know.
You do x and x, you get x squared, not x.
Because this is going to give me minus 3x times 256. It's going to give me x. Imagine we sat there and we did 5 times this. We get this number. 5 times minus 256kx. We're going to get a number with an x, right?
Oh, okay.
5 times this, we're going to get a number with an x squared. But then after I've done 5 and multiplied all this out, what am I then going to try to do? Minus 3x.
Yeah.
So minus 3x times this is going to give me something with an x in. And then we would collect like terms. Yeah, we'd collect them together. We'd add them together.
Yes, does that mean we do minus 3x times minus 256kx as well?
No, because if I was to do minus 3x times minus 256kx, you tell me what's x times x? X squared. Do I want the coefficient of x squared? No, I want the coefficient of x. Okay, it's like using your brain. No, I meant like I meant use your brain to I'm sorry, I didn't mean it like that. Okay, so then right, I need a calculator. So then we're going to have minus 1,280 kx plus, what is it? Minus 3 times 256. Minus 768x. Okay? Right, now this is something, we can't just add these numbers together now. Okay, it doesn't work like that. What we know is that this is actually minus 6768 minus 1280k, lots of x. Okay, don't forget there's a k in there, right? Okay, so now I've worked out the coefficient of x, and I've worked out the constant. Okay, let's read the question. I forgot what it said.
The expansion of x.
So the constant terms is 3 times the coefficient of x. What does that mean?
3 times 1,200.
No.
What does it mean then?
What does it mean? The constant terms is 3 times bigger the coefficient of x. So that means the constant term is 3 lots of the other one. Okay, so some of you did 3 times 1,280, right? Which is incorrect. Right.
It's 3 times bigger.
Because it's 3 times bigger. So let's read.
Think like a ratio.
In the expansion, so the constant term is 3 times bigger than the other one.
Doesn't that mean constant term? Normal term is 3 times the x.
No. So this means, so if you've got to think about it, so the constant term, so I was saying the blue term is 3 times bigger than red. So 3 times red is blue.
Oh, okay.
Yeah? Okay, so now that we've got that, what is this now? I mean, we're practically back in primary school. Yeah? Now we figured all this out. Let's go. So 1,280 equals minus 3,840k minus 2,304. Okay? So then I'm going to have minus 3,840k equals 3,584. It's just everyone's happy with the rearrangements, yeah? Divide both sides. So 3,584 divided negative 3,840. And then we're going to have minus 14 over 15 as our k. Yeah, it's beautiful. Okay then, you can take it away. So number 4, using the laws of logs, solve this. Now this is probably the nicest question ever with a bit of a sting at the end. Okay, so are they pretty much all in the same base that we need for right now? Yes. So what do we know? We know that the log 3, 32 minus 12x equals log to the base 3 of 1 minus x all squared plus 3. Now, well, what am I going to do? I'm going to take away the log, right? So I'm going to have log 3, 32 minus 12x minus log 3, 1 minus x squared equals 3. What do we know if we take away logs? Division. log to the base 3 of 32 minus 12x over 1 minus x, all squared equals 3. What does that mean? Absolutely. Smartest person here. 3 to the power of 3 equals 32 minus 12x over 1 minus x squared. So, what is 3 cubed? 27. 27. Is everyone happy if I just multiply this up here? 1 minus x squared equals 32 minus 12x. Okay, so what am I going to do now? I'm going to expand the bracket. What is 1 minus x squared? I'm going to get x squared minus 2x plus 1. Okay, everyone should be happy expanding that. If you can't expand that in your head still, you really need to think about doing your A-levels next year. Okay? But on a serious note, like, everyone should be happy. No one should have given me just 1 plus x squared. Yeah? So we're going to get 27x squared minus, what's 27 times 2? 54x plus 27 equals 32 minus 12x. So 27x squared minus 54 plus 12, what's that? Minus 42x. 27 minus 32? Minus 5 equals 0. Okay. Going to be a bit lazy. Shove this into a calculator. What do I get?
We'll get x
5 over 3.
minus 5 over 3.
Minus 5 over 3.
And x equals 1 over 9.
And 1 over 9, okay? If you don't know how to use your calculator, use the quadratic formula. Negative 1 over 9.
Yeah, but it's not negative 5.
It's not negative 5 over 3. Did you get this wrong?
I think so.
Yes. Okay. So, now guys, this is really important. We got 5 over 3 and minus 1 over 9. I know what you're all thinking. Let's reject the negative. Yeah? Why? Yeah, because we can't have a negative log. No. This is correct. We can't have a negative log, but this is where this phrase has been taken out of context. Okay, we need to substitute it back into the original equation. Yeah, but listen, if we substitute in here 1 over 9, okay? If we substitute in 1 over 9, we're going to get 1 minus 1 over 9.
Miss x equals Shabab, x equals minus 5 over 3.
Okay, sorry guys, minus 1 over 9. If I substitute this in, if you think, I'm still going to have, this is going to be minus times minus, minus times minus. We're going to have a positive, right? We're going to have a log of a positive number. That's fine. If I substitute in 5 over 3, what's going to happen here? I'm going to have 1 minus 5 over 3, which is actually less than 0, is it not? We're not allowed that. So in this particular one, we're going to reject this one. If you do not write reject and you have 5 over 3, you do not get full marks. Okay, we're going to accept the negative in this case. So you know whenever we say we can't have a negative log, that doesn't mean our x can't be negative. You know, we always have to go back in and substitute it. Hopefully this gives you something to think about. Okay, question 6. Now, I feel like question 6 was a little bit funny. Some of you with the show that part, and then the rest of it, I really don't know what happened. So, let's go for it. So, where a and b are integers. So, here we go. F of x equals 3x squared plus ax squared plus bx, okay? Minus 10. When f of x divided by minus 1, the remainder is k. Okay, so what are we going to substitute in? 1. Right, so if I substitute in f of 1, I'm going to get 3 plus a plus b minus 10 equals k. So realistically, a plus b minus 7 equals k. Brilliant. When it's divided by x plus 1, the remainder is minus k. So what do I sub in? Negative 1 equals negative 3 plus a minus b minus 10 equals negative 10k. So I'm going to get a minus b minus 13 equals negative 10k. K is a constant. Show that 11a plus 9b equals 83. What?
I don't understand what the other stuff.
Yeah, so k is a constant. So, I've got simultaneous equations. How do I get rid of k?
You apply the k into the...
Yeah, I'm going to substitute in, right? So I'm going to have a plus b minus 7 is now k. Where am I going to put this? I'm going to substitute this technically here. Yeah? So now this becomes minus 10 lots. So a minus b minus 13. So what do I have? A minus b minus 13 equals minus 10a minus 10b plus 70. So I'm going to have 11a plus 11b equals 83.
Why is it minus 13? Isn't it
Oh, wait there. This is 9b. Minus 1 plus 10. Okay? Therefore, proved. Okay, what was the question?
why is minus 13? Isn't it minus 7? Because when you expand it,
So this here, minus 3 minus 10 is minus 13.
isn't it plus?
No, because minus 1 cubed is negative 1. So it's negative 1 times 3. Perfect. So we've proved it. It says, given also that 3x minus 2 is a factor. So what does that mean? F of 2 over 3 equals 0. So if I substitute this in, what am I going to have? So I'm going to have 3 lots of 2 over 3 cubed plus a lots of 2 over 3 squared plus b lots of 2 over 3 minus 10 equals 0. And we know that because it's a factor. Okay, so then this is going to give me 4 over 9a plus 2 over 3b. And then if I just do that in my calculator, I'm going to get 82 over 9. Okay, now to make my life a little easier, I can multiply through by the largest denominator. So I'm going to get, if I multiply everything by 9, 4a plus 6b equals 82. So now that I've done that, I'm going to have simultaneous equations. We already had one earlier, and now we have this one. So if I have 11a plus 9b equals 83, and 4a plus 6b equals 82. Okay? So multiply, substitute, rearrange, however you want to do this. Yeah? What was the majority? By 4 and 11?
Yeah. I did by...
So 44a plus 36b equals 332, and then 44a plus 66b equals 902. Okay, if I take them away from each other, I'm going to get 0 minus 30b equals negative 570. So what does b equal? 19. Substitute into any. So 11a plus 9 lots of 19 equals 83. A is going to equal negative 8. Are we happy with that? So now we know that means we have 3x cubed minus 8x squared plus 19x minus 10. This is what g of x equals. Okay? Now what does it want us to do? We've got to factorize it. So what we're going to use? I'm a silly Billy. So 3x minus 2. Long division. I'm a silly Billy just helps us to remember. Okay. So into, how many 3x's go into 3x cubed? X squared times. So then multiply. So we're going to have 3x cubed minus 2 times x squared minus 2x squared. Okay, subtract. Minus 8 minus minus 2. Minus 6x squared, and then we're going to bring down the 19x. Okay, multiply. 3x times what is minus 6x squared? Minus 2x. Multiply. So we're going to have minus 6x squared minus 2 times 2 is plus 4x. Take away, we're going to get 0. 19 minus 4, 15x, and then we're going to bring down. Multiply. 3x times what is 15x? 5. Bring down, multiply 5 times 3x is 15x, 5 times 2 is minus 10. This should give us 0 because it's already told us it's a factor, right? So we shouldn't have any remainder. So therefore, we're going to have 3x and minus 2x squared minus 2x plus 5. Can we factorise x squared minus 2x plus 5? Yes or no? Can we factorise that? No, we can't. So this is fully factorised form. Okay, so question 6, part A, was a little bit proofy. We've got to show that PQR is 90 degrees. Okay? If PQR is 90 degrees, what facts do we know? How could we show it's 90 degrees? Yeah, so the two gradients multiplied together. So the gradient multiplied by the perpendicular gradient should equal minus 1. Or, what else do we know about 90 degrees? RP would be the diameter, but how could we prove that's the diameter? We could, but we don't have a different point. Okay? What else do we know about right angled triangles? Pythagoras. We know that a squared plus b squared equals c squared. Yeah, if a and b meet at 90. Either one of these, it's only 2 marks. Okay, but we have to pretend the examiner's an idiot. Okay? So, which one should we go for? The first one. Okay, so let's have a look at the gradient. So let's do this. So if PQR equals 90 degrees, then the gradient of RQ multiplied by the gradient of PQ should equal minus 1. Okay? Why should it equal minus 1? Yeah. No, not negative reciprocal. If PQR equals 90, then MQR times that because they are perpendicular. Okay, so let's have a look at the gradient of RQ. What is the gradient of RQ? So minus 13 minus minus 26 over 15 minus minus 7. What do we get? Minus 4 over 22, which equals negative 2 over 11. Okay, what is the gradient of PQ? Okay, so you're going to have minus 13 minus 14 over 15 minus 23. What do we get? Minus 44 over, what's 15 minus 23? 8? Negative 8, which is going to give me positive 11 over 2. Minus 2 over 11 times 11 over 2 equals minus 1. Therefore, PQR equals 90 degrees. I know it's a lot for 2 marks. However, it's really good that we get into the habit of writing it like this, because when we look at the proof question later on, you're going to see why. Okay? You could have also used Pythagoras. Right? Perfect. So we've proved it. Brilliant. Hence or otherwise, find the centre of C. Now, do you remember the circle theorem? You know, if this goes through the radius, If it goes through the centre, then it's going to make 90 degrees. They've told you it's 90 degrees, so the radius is in fact the midpoint of RP. Yeah? So what is the midpoint? 23 to 7 is what? So 15, 8? Yeah? 14 to minus 26? Minus 6, okay? If you don't know how to do that, you can always add them. 23 minus 7, and then divide it by 2. Okay? 14 minus 26 divided by 2. Okay, so that's how you can work it out. Right, and then it wants us to work out the length of the radius. Okay, what do we know about the radius? If we now know that this is 8 minus 6, we can just use Pythagoras on these two. So, what's the length between 8 and 6? Between 8 and 23? It's 15. Squared. Between minus 6 and 14, what's that? 20. So what's 15 squared plus 20 squared? 625? What's the square root of that?
25.
Equals 25. So my radius is 25 and my centre is 8 minus 6. Perfect. Yeah, so just to confirm, the circle theorem. This is how I know it's the diameter. Do you remember that circle theorem from GCSEs? Yeah? Right then. So, given that a point S lies on C such that the distance QS is greatest. Guys, what is the greatest distance QS? It means S must be here such that QS is a diameter. Right? Find an equation to the tangent to C at S. So now we want to find the equation of the list line at S. Right? Now, there's many different ways you can do this. Oh my. So, this is 8 minus 6. Right. Okay, so what we need to do now is we need to find the points of S. Okay. Probably the simplest thing you can do is this. How do you get from 15 to 8? Minus 7? So just minus 7 again. And then we're going to get to 1. Okay? I know, it's crazy, isn't it? It's thinking outside the box, this is. Right? Why have I done this? Because I know the radius is half of the diameter. Okay, it's going to be the same gradient. So if I've had to move minus 7, I've got to keep minus and 7 to get to this S. How do I get from minus 30 to minus 26?
24.
I have to go up 24. So what's minus 6 plus 24? 18. I mean, it's mad, isn't it? I know. This is called thinking outside the box. Don't make life too complicated. Yeah? How would a child do this? You've technically been given a point and a midpoint. How would you find the next point? Yeah. There's no need to make life complicated, right? So then, what do I need now? I need the gradient of this, and then I'm going to find the negative reciprocal. So the gradient of this is the gradient of the radius, technically, between the centre and S, is going to be minus 6 minus 18 over 8 minus 1. What's minus 6 minus 18? Minus 24 over 7. Is that right?
Yeah.
Okay, so what is the... so what's then the tangent? Remember, I need to do the negative reciprocal. So what am I going to get? Oh my, 7 over 24. Okay, because it's going to make 90 degrees. Yeah. So now I have a gradient. I have my point S. I'm going to use y equals mx plus c. So I'm going to have 18 equals 7 over 24 lots of x plus c. So 18 minus 7 over 24 equals c. What does that give me? 425 over 24 equals c.
So y equals
But it wants it ax plus by plus c. So now I get y equals 7 over 24x plus 425 over 24. So I'm going to multiply everything by 24. It's nice and easy. 24y minus 7x minus 425. Now this is crucial. There's about 7 of you in here that didn't do this. What does it equal, guys? 0. Yeah, if you do not put equals 0, you're not going to get the mark. Okay, guys. Everyone happy with this question? Yeah? Okay, first of all, I can tell you straight away there were some mistakes in this question. And I don't know, could you spot probably what the most obvious mistake was in this question? Absolutely. We go from degrees to radians. Wow. Yeah, I know. It's not very nice. However, let's work through this one question at a time. Right, so let's do part A. So part A says solve between minus 90 and 90. We'll forget about that for a second. We've got sines and causes. A lot's happening. Okay? So what's the best thing to do?
Divide this by 3 equals 2x minus 15 divided by 3. So
Yeah, like we need one trig function, right?
Yeah, miss, don't you make it tan?
So, I'm going to divide both sides by cos of 2x minus 15. So are we ready? So, 3 sine 2x minus 15 divided by cos of 2x minus 15 equals 1. What does sine over cos equal?
Tan.
Silly cow. What is silly cow? Tan. It's a way to remember it. So we're going to get 3 tan 2x minus 15 equals 1. So that means tan of 2x minus 15 equals a third. Okay, so now this means 2x minus 15 equals inverse tan of a third. I'm going to make sure my calculator's in degrees. When I do this, I get 18.4 degrees. Okay? Now, I'm not going to add 15 and divide by 2 yet. That would be silly. What I am going to do is I need to change my interval. What's my interval? Between minus 90 and 90? So if you think minus 90 is less than or equal to x is less than or equal to 90, what have I done? 2x minus 15. So what have I done? I've doubled it and taken away 15. So if I double it, I get 180.
Did you double it first?
Yeah, I doubled it first. Think about what happened to x first. You tell me what happened to x first. Yeah, it got doubled. If I took away 15 then doubled it, it'd look like this. Different. Yeah? So, because it's doubled here. 2x minus 15. So I doubled it. Now what am I going to do? Take away 15. Minus 180 minus 15. And then 165. This just gives me my new boundaries, okay? So we're going to use the cast diagram. Now, first of all, it doesn't matter whenever you start this, we're just plotting 18.4 degrees. That's it. Where is 18.4 roughly if we start on this line? Okay, it's roughly here, isn't it? Okay, this is 18.4. Okay? Then, with tan, it's just like carry on the diagonal line. There we go. So we know that this is 18.4. Okay, so here we go again. So now, we start at 0, and we've got to go to 165. Where is 165, roughly? Here. How many times did I cross it? Once, 18.4. Yeah? Okay, now let's go the other way round, because if we then going to go from 0 to minus 195. Start at 0, I get to here. What is this value? Yeah. This is not 198.4. It's 180. Negative 180 plus 18.4. So this is negative 161.6. So you imagine this is 0, this is minus 180. So you tell me, Of course, this has got to be less than 180. Yeah? And then we keep going round and we stop about here, roughly, right? That's it, done. So we're not done yet, though. 2x minus 15 equals 18.4 and negative 161.6. What am I going to do? I'm going to add 15 and then divide by 2. Okay, so if I add 15 and then divide by 2, I'm going to get 16.7 and negative 73.3 degrees. This is going to give us a full 4 marks, okay? Yeah, so I just did this in the calculator. 18.4 plus 15 divided by 2. Yeah, okay? So there we go. Right, so that's that question done. Next question. I want you to read this, and what do you think the first thing I want you to do is? Stop what you're doing. Change your calculator right now into radians. Okay, if not, you're going to fail. Are we ready? So, we have 4 sine squared theta plus cos theta equals 3. What do we know about sine, cos, squareds, anything like this? We know that sine squared theta plus cos squared theta equals 1. So what does sine squared theta equal? 1 minus cos squared theta. So I'm going to substitute this into here. So I'm going to have 4 lots of 1 minus cos squared theta plus cos theta equals 3. Sorry, the 8, I don't know what happened, it just didn't compute. There it is. The 8 didn't disappear. I just forgot to write it down.
Do 1 minus sine squared theta and then substitute it into cos?
No, because this is just cos. You don't have cos squared theta, do you? If you wanted to substitute cos, you'd have to do the square root of 1 minus sine squared theta. Yes. Right, guys, then you're going to have 4 minus 4 cos squared theta plus 8 cos theta equals 3. It's pretty much looking a bit like a quadratic, isn't it? So I'm going to move everything to the other side. So I'm going to have 4 cos squared theta minus 8 cos theta minus 1 equals 0. Okay, so we can factorise this, can't we? Yeah? So, or you can use, if you can't factorise, just use the quadratic formula, where a equals 4, b equals negative 8, c equals minus 1. Okay, so when I do that, I get cos theta equals 2 plus root 5 over 2, and 2 minus root 5 over 2. Now, 2 plus root 5 over 2, believe it or not, is greater than 1. Okay, so what are we going to do? Reject. Okay, even if you try to put that into your calculator, shift sign cos of this is going to say syntax error. Okay, so then we're going to get this. So, when I do theta equals cos to the minus 1 of 2 minus root 5 over 2, what do I get? 1.45. Now, if I was to draw my cast diagram, think about this. This is 0, this is pi.
I'm sorry, show you in radians.
I'm in radians.
I've got a different answer.
Okay?
1.68.
1.68. Okay. Yeah. 1.69. Okay. So, if you think about this, what is pi? What's pi? 3.1. Yeah?
Oh, okay, yeah.
What's half of pi?
1.8. No, 1.
No, just do pi divided by 2 into your calculator.
1.57.
1.57 is 1.69 greater than 1.57.
Yes.
So when we're drawing our angle from here, if you think, it's going to be roughly here. We're dealing with cos. Where do we reflect? In the horizontal line. 1.69. Now, we didn't have to change any, this is just 0 between theta and 2 pi. So all we're then going to do is 2 pi minus 1.69, and that's going to give us our other answer. which is 4.59. Okay, because if you think about it, start from 0, we go round once, 1.69. We go round, we hit it here. How do we find this angle? 2 pi minus. And that's it. Perfect. Question 8. A metal pot is repeatedly hit in order to drive it into the ground. Given that in the first hit, the post is driven 100 millimetres into the ground. Okay? Yes, darling. Of course you can. Then, on the second hit, the post is driven an additional 98. What does that mean?
On top it's minus 2.
It means 198? Right, let's have a think about this. Guys, read the question, please. What does it say? So, on the first hit, the post is driven 100 metres into the ground. On the second hit, the post is driven an additional 98 millimetres into the ground. Okay, so then we went 98. Then after that, an additional 96, okay? Now, part A says, show the post is driven an additional 62. So we know that additional each time means this is what's happening. So we can clearly see that we have a difference of minus 2. Our A is 100. And we want to know on the 20th hit. So what does that mean? U20 equals A plus N minus 1 lots of D. So we're going to get 100 plus 19 times minus 2, 100 minus 38, which equals 62. Guys, it says show that. You need to be showing this, yeah? Then it says find the total distance the post has been driven after 20 hits. So actually, technically, what we're doing now, we're finding S20 equals N over 2 lots of 2A plus N minus 1 lots of D. I'm going to shove this into my calculator. I'm going to get 1,620. And we are talking about millimetres, aren't we? I mean, that's really unrealistic, isn't it? You're telling me on the 20th hit, someone's managed to hit that 1,620 metres into the ground. Surely they're going to break through something. Oh, yeah, we're in millimetres, not metres. Okay, this is more realistic. Yeah, thanks. Okay, then. Given that for each hit, after the 20th hit, the additional distances the post travels from a geometric sequence with a common ratio r. Okay? Now, remember, what was the 20th hit? Was 62, right? So let's pretend we start at 62. On the 22nd hit, we're down at 60. So 62 something 60. Okay? Find r. Now, what do we know? Technically, we're multiplied by r, multiplied by r. So this means 62 times r squared equals 60. So r squared equals 60 over 62. R equals root 60 over 62. Now, some of you, for some reason, had like the 21st root or some crazy stuff. Now, it wants three significant figures. So 0.984. Okay? Perfect. So now we know what R is. Now, okay, now this is the bit where it's a bit complicated because we've got a geometric and an arithmetic happening at the same time, really, technically. So after a total of n hits, the post will have been driven more than 3 meters. Okay, now this is where, good job, someone told me that we were dealing in millimeters, because now we've got two different things going on. What have we been dealing with the whole time?
Millimeters.
Okay, so what should we convert this to? Millimeters. Okay, so 3 meters is what?
3,000.
Are you sure?
Yeah.
Yeah?
Each centimeter is.
Okay, so we're going to multiply it by 100. Why? because that converts to centimetres, multiplied by 10y, because that converts to millimetres. So we're going to have 3,000. So we want to know after n total hits. So how much was it already hit after 20? Okay, so 1,620 plus certain amount of sum has to be greater than 3,000. Okay, now this sum here is the geometric sum, considering we're starting from 62, right? We've already been told this. So technically, that means Sn has to be greater than 1,380. So, what do we know? What is the geometric thing for Sn? A 1 minus r to the power of n over 1 minus r. Okay, so what was my A again? It's 62, okay? We're going to go with this one.
Miss, why'd you put the inequality?
62, because we want to know after a total hits n. More than. So this wants to be more than. Yeah? So 62 lots of 1 minus 0.984 to the power of n over 1 minus 0.984. This needs to be greater than 1,380. Okay, this is where we're going with ourselves right now. So, this means that 62 lots of 1 minus 0.984 to the power of n has to be greater than 22.08. Okay, so now we're going to have 62 lots of, no we're not, we're going to divide by 62. So 1 minus 0.984 to the power of n, okay, is going to be greater than, well, no, let's divide by 62, take away 1. So this is going to be greater than 0.356. No. 0.644. Perfect. Negative. Right, now what am I going to do? Change the sign. I divided by 62 and then took away 1. Yeah, we have to use logs. Happy? Okay, so log to the base 0.984 of 0.644. What does this equal? N. So n equals 27.3. Now, this doesn't necessarily mean we round up or down. I always think just work it out. Okay, just put it in here and see what becomes true. So, n equals 28. Now, that doesn't actually mean 28 hits, because how many times did we already hit it? 20. So now, 28 plus 20. What is it?
48.
It is 48. Well done. 48 times, okay? Don't be silly.
And write 50.
And write 58. Okay, double check. Well done. Okay, question 9. So clearly we can see this is definitely going to be an integration question, yeah? Area under a curve. Seem to have 2 shaded regions. So figure 2 shows this. The curve C with the equation y equals x minus x squared. The line with the equation y equals mx, where m is a constant and 0 is less than m is less than 1. Okay. The line and the curve intersect at the origin and at the point P. And we already can tell that because we don't have any y-intercept on either, right? There's no constant. And they obviously intersect at P. Find in terms of m the coordinates of P. So, first, what is the first thing we're going to do to find the coordinates of P? What do we have? Yes, simultaneous equations, right? So we're going to have mx equals x minus x squared. So I'm going to have x squared plus mx minus x equals 0. So technically, this is x squared plus m minus 1, lots of x equals 0. Everyone happy? Yeah? I factorised out x. If you think here, x times m, x times minus 1. Okay? Now, the best way to think about it is when we have like this m minus 1. What is m minus 1? It's just a number. Okay, it's just a number. If m was 4, m minus 1 would be 3. Yeah? Think about it like this. If you had x squared plus 3x equals 0, what would you do? You'd factorise out an x, wouldn't you? Can we see that? Yeah? So this is what we're going to do. If we factorise out an x, we're going to get x plus m minus 1 equals 0. Okay? So, what do we know then? We know that x clearly equals 0, or, you know, here we'd say, right, well, this means that x plus 3 equals 0, so x equals negative 3. Okay? We're going to do the same here. This means that x plus m minus 1 equals 0. So if we add 1 to both sides, take away m, this is how we get the 1 minus m. Yeah? So now we have our x coordinate. How are we going to find our y coordinate? Substitute back in. We know that y equals mx is probably the easiest one to do. So y equals m lots of 1 minus m, which some of you may have expanded to m minus m squared. Now, I'm pretty sure it said coordinates of p. So what do? I'm going to get some brackets, don't I? Right? So x is 1 minus m. What's y? M minus x squared. There we go. Nice and simple. So actually it was pretty simple when we think about it. When in doubt, put some numbers in. Yeah? And really just think outside the box. Brilliant. Right, so right now, it now says the region R1, shown shaded in figure 2, is bounded by C and L. Show that the area of our R1 is this, okay? The region R2, also shaded in figure 2, is bounded by C in the x-axis. Given that the area of R1 is equal to the area of R2, find the exact value of M. Okay, sorry, read too much into the question. Right, let's just stick with the part. So, if I integrate this one, okay, between P and 0, technically, hopefully my pen's charged. Technically, I'm going to find the area under the curve between P and 0, right? So I'm going to find this whole area. Yeah? Now also, I then need to take away this area, don't I? But guess what? This is a right angle triangle. So I don't need to integrate. I mean, you can integrate if you want. There's more than one way to do this. So let's do this then. So let's integrate x minus x squared between, what was our x coordinate of P? 1 minus m. Between 1 minus m and 0, right? With respect to x. And then I'm going to take away the area of this triangle, which is base times height divided by 2. Okay? But what is my base in this case? Is my x coordinate, and what is my height? My y coordinate. So my x coordinate is 1 minus m times my y coordinate, m minus m squared. Okay? This is technically going to give me the area. Now you can do this any which way you want. So, are we ready? Let's go for it. Oops. So if we integrate x, what do we get? Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. So we're going to substitute in 1 minus m and 0. Now I already know if I substitute in 0, what's this all going to give me? 0. So I'm just going to substitute minus m. 1 minus m. So minus, then I have this 1 minus m times m minus, do you know what? Let's actually multiply this out. Okay, so what's 1 times m? 1 times minus m squared. Minus m times m. And then m times minus m squared
Plus m is minus m.
plus m cubed all over 2. Perfect, right? Okay, so now I'm going to substitute in 1 minus m squared over 2 minus 1 minus m cubed over 3 minus the one we're going to have here, m cubed minus 2m squared plus m over 2. Great. Okay, what do you think we now have to do? Common denominator. So what is common between 2 and 3? 6. So I'm going to put them all over 6. So if this is over 6, and then did anyone expand all the brackets? I did. You did? Okay, I might have to do it. Right, so if I put this over 6, I know I'm going to have 3 lots of 1 minus m squared, right? Minus 2 lots of 1 minus m cubed over 6 minus 3 lots of m cubed minus 2m squared plus m all over 6. No way, am I going to have to expand all this? All right, well, let's do it then. Let me just snip it. Must be an easier way, surely. But if that's what you did, well, we're on with that. Let's move this up here. Okay. So, right, I'm going to try and expand this quickly, but obviously there's mistakes to be made, right? So we're going to have 3m squared minus 6m plus 3. Someone best be checking this. Right? M cubed, 1 minus m cubed. So, how could I expand 1 minus m cubed quickly? What do we know about 1 minus m cubed? Yeah, but think about binomial expansion. I'm not saying we have to use the formula, but we know it's going to be 1, 3, 3, 1, don't we? Yeah? We know 1's going to be 1. No one's going to be, is this going to be negative m cubed? It's only the negative that might thingy us out. And then this is going to be negative m, positive m squared. Can you see how quick I've done that? Yeah? Okay, just remember binomial. It'll help you. That's the whole point of it. And then we're going to multiply all that by 2. Negative 2. Oh my God, where have I gone? So if I multiply all this by negative 2, I'm going to get negative 2 plus 6m minus 6m squared plus 2m cubed. Okay, and then the last one, remember these negatives, okay? Minus 3m cubed plus 6m squared minus 3m. Okay, and the whole thing is over 6. Okay, oops. Right, let's simplify like terms. Okay, where's my m cubes at? 2m cubed minus 3m cubed, what do I get? Minus m cubed, brilliant. Squareds, 3m squared minus 6m squared plus 6m squared, what do I get? Plus 3m squared. Minus 6m plus 6m minus 3m. Minus 3m. Hi, darling. I'm good, thank you. And then plus 3 minus 2? Plus 1. Over 6. Now, what do we notice? That this is actually 1 minus m cubed over 6. Can you see this is the same as what we expanded earlier? Yeah? Okay? Crazy, isn't it? And colourful. Okay, so then what do we write? Therefore proved. We're doing the same paper as yesterday. Okay. Now, it says, given that the area of R1 equals the area of R2. Now, the area of R2 we don't know yet. We only worked out that triangle bit. All right? Don't be silly. and just assume. So, how are we going to work out the area of, we know the area of R1, it's given us 2 here. How are we going to work out the area of R2? We need to find out this point, don't we? Yeah? So this is when y equals 0. So what does x equal? 1. Okay, we know that x equals 1 because we're going to have x, 1 minus x. So we know that x equals 0 and x equals 1 is a solution. So we know this is where x equals 1. So if we integrate the curve between 0 and 1. So if we integrate between 1 and 0, x minus x squared, what do we have? X squared over 2 minus x squared over 3. And we're going to substitute in 1 and 0. So 1 squared over 2 minus 1 cubed over 3 equals a half minus a third. What do we get? Which is 1 over 6. Okay. So if the total area is 1 over 6, right? We don't even need to work out the area of R2 technically, because we know the total area of R1 and R2 is 1 over 6. Yeah? If R1 equals R2, thank you, that must mean that R1 equals half of this, no? We don't even have to worry about R2. So we've worked out the total area under this graph between 0 and 1 is 1/6. If R1 equals R2, that must mean that R1 or R2 actually equals half of this. Do we understand what I'm saying here? Yeah? If this is R1 plus R2, but also R1 equals R2, that must mean that R1 equals half of the 6, which is 1/12. So that means 1 minus m cubed over 6 equals 1/12. So we don't even have to worry about figuring out the area of R2. So that means 1 minus m cubed equals a half. Okay, technically, should we just do the cube root of a half? 1 minus m equals the cubed root of a half. So m equals the cubed root of a half minus 1, all multiplied, actually, let's do negative m equals this, makes everyone's life easier. So that means positive m equals 1 minus the cubed root of a half. What does it want the answer in? Exact value. Is this the exact value? Did anyone check the mark scheme? Let's have a look at it. Absolutely. Okay, now in the mark scheme, what they have done is actually written it slightly nicer and put 1 over the cubed root of 2, because we know that the cubed root of 1 on the numerator is 1. Okay, so there we have it. So in the mark scheme, they have done three different methods, in fact. Okay, personally, the method that I've shown you, with the logical and then like using your brain, that works for me. However, if you've done it a different way, that's okay. Yeah? How do we feel about this question now? Good. Okay, and how lovely. We finish with a beautiful proof question. Okay. Question 10. Proof by counterexample. Okay, what does counterexample mean? If it's only worth 1 mark, it means we've got to find a number for which this is not true. So, if p is a prime number, then 2p plus 1 is also prime. Oh, perfect, right. So, let p equal 7. Okay, 7 is prime. No, we can't use 4 because 4 is not prime. We could use 2, but 2 times 2 is 4, plus 1 is 5, yeah? I need a counter example. So let P equals 7. 7 is prime. So 2 lots of 7 plus 1 equals 15. Yeah? 15 is not prime. Okay? Because, why is 15 not prime? Yeah? 5 is a factor. Therefore, more than 2 factors. And we were probably writing a bit much. Therefore, not prime. Okay? It's just really good. So, therefore, not true. Therefore, proved. Okay, probably written way too much there. Should we see what the mark scheme says? Okay, so the mark scheme says, yeah, so you have to identify a counterexample and make a conclusion, shows not prime. So here, we put P equals 7, 2P plus 1 equals 15, which is not prime, not true. You have to really say that the statement is not true. If you have not put that the statement is not true, you're not going to get that 1 mark. It's crazy, really, isn't it? Like for 1 mark, you have to show that you have to substitute in a number and then do this. Okay, now the next one. Use proof by exhaustion. What does exhaustion mean? Got to show all possibilities. That if n is an integer, then this is always even. Okay, so n's 5 n squared plus n plus 12. Okay, is even. First of all, right? If n is an integer, what do we know? Yeah, if n is an integer, all integers are either odd, what's it, odd? 2n plus 1, or even. What's even? Okay, can you see how I've stated this? I told you, the examiner's an idiot. Treat them like that, right? Write that down. Tell them that all integers are either odd or even, okay? This is how you have to, when we're doing proof, you have to do each step. Okay, so let's try. If odd, okay? We're going to have 5 lots of 2n plus 1 squared plus 2n plus 1 plus 12. Yeah? So what are we going to have? 5 lots of 4n squared plus 4n plus 1 plus 2n plus 13. So we're going to have 20n squared plus 20n plus 5 plus 2n plus 13. So then this is going to be 20n squared plus 22n plus 18. Okay? Now, this is going to give me 2 lots of 10n squared plus 11n plus 9. Okay, this is the thing here, is what did we say an even number was? 2n. Yeah? So we have to show that this is now 2 something. 2n is 2 something. Okay? And you have to show that 2 is a factor of all these numbers. So 2 is a factor, therefore even. Okay? So we've shown it for odd. Now what are we going to show it for? If even. So 5 lots of 2n squared plus 2n plus 12. So we're going to have 5 lots of 4n squared plus 2n plus 12. So we're going to have 20n squared plus 2n plus 12. Okay. 2 lots of 10n squared plus n plus 6. What do we also notice? Yeah. 2 is a factor. Okay. Therefore, even. Now you can see I factorised 2 out of all of it. Okay. Yeah. Not just some of it. Now, what you then have to do is say a statement along the lines of Yes, they are both even. Okay. And then we're just going to reframe the sentence. Okay. So they are both even. Therefore, if n is an integer, then 5n squared plus n plus 12 is always even. Therefore, proved. Okay, so you can see we've now done everything possible. Okay? Perfect. So that's it. That's the paper. Well done. Yeah, you did get 3 out of 4. You need to factorize out 2 on both of them. That's what I'm telling you. It doesn't matter. So it's really important, because you've stated that an even number is 2 lots of something, we then need to factorize 2 out of the something to show that it's done even. Yeah? Okay. Right. Good luck for your exam, everyone. You've got this.